Hello Genians! Welcome back to another CE board exam question. This time, this was given last May 2014. The question: a vertical cylinder has a circular base of radius 3.5 meter and a height 3.95 meter. It is 1/3 full and is being filled with water at a rate of 0.5 meter cube per second and oil at a rate of 0.5 meter cube per second. The specific gravity of oil is less than that of water. How fast is the surface of oil rising? Now here, of course, when we say how fast, means this is the rate of change of the height with respect to the time. Meaning, it is the derivative of the height. So, to solve this one, we have to draw first, because it is a vertical cylinder, that means having a rough sketch of the cylinder. And it is 1/3 full. That it is 1/3, that means it's like this. 1/3 full. So the height is 3.95 meter. So this is the height of the cylinder. 3.95 meter. And the radius, of course, is equal to 3.5. So means this one, from the center to this one, this is the radius, of course, which is equal to 3.5 meter. The radius from the center to this edge. Because this, of course, the top is circular. It's a circular cylinder, vertical cylinder. Now, this can be solved using the volume of cylinder formula, which is equal to pi r squared h, where V is the volume. Pi is equal to 3.14 in radians. The radius is equal to 3.5 meter. And the height, of course, is unknown. So what we're looking for here, what is required here is how fast is the surface of oil rising, means the rate of change of the height with respect to time, which is the derivative of h. So this is the one we're looking for. Now, how we will solve this one? We have this V, volume cylinder, is equal to pi r squared h. Now, if we will substitute the values of this one, volume is equal to pi. What is the radius is equal to 3.5 squared, and the height is equal to now. So the volume is equal to pi times 3.5 squared h. Now, if we will take the rate of change of the volume with respect to the time, or the derivative of V, this is equal to 3.5 squared times the pi, which is 3.14, times the derivative of h, with respect to time. Now, we have the given derivative of h with respect to time, means because we're talking about the surface of oil rising, what is the derivative of the volume, or the change in volume with respect to the time, is equal to 0.5 meter cube per second. So it is 0.5 meter cube per second. So this, we can substitute it here. So 0.5 is equal to 3.5 squared times 3.14 dH dt. Simplifying all this one, dH dt is equal to 0.5 divided by 3.5 squared times 3.14. Now, of course, simplifying this one using the calculator, this is equal to the rate of change with respect to the time is equal to 0.013 meter. That is the one we're looking for, the dH dt. So if we will put this one in the diagram here, in the drawing, this therefore is this one. This is the dH dt. The rate of change of the height with respect to time of the oil. So how fast is the surface of oil rising? So that means the height, which is equal to 0.013 meter. Another CA board exam question, which is about the rate of change also, is a question which was given last November 2013. The question: the height of a rectangular box is 10 centimeters. Its length increases at the rate of 2 meters per second. Its width decreases at the rate of 4 centimeters per second. When the length is 8 centimeters and the width is 6 centimeters, what is the rate in cubic centimeter per second at which the volume is changing? Therefore, what we're looking for here is the derivative of V. It is come to the derivative of V means the rate of change of the volume when it comes to time. Now, if we will draw the rectangular box, see, if this is the height, which is 10 centimeters, this is the height, and if we will designate this one as X, and this is the width, L, we will see it Y. Therefore, what is given here is the length, which is, we will consider this one as the length, and this is the width. This is the length, and this is the width, and this is the height. Now, the given here are the dx dt, which is equal to, which is the rate of change of the length, which is equal to 2 centimeter per second, This is centimeter, sorry. And of course, the width, each width decreases at the rate of 4 centimeters. So this is the width. So it decreases, means we'll see it is negative because it is decreases. Negative 4 centimeter per second. So these are the given. Now, in this problem, we will use the volume formula of the rectangular box, which is equal to the area times the height. What is the area? X times y multiplied by y times the height, which is equal to 10. This is the volume of the rectangular box. Therefore, if we will take the derivative of this one, which is the rate of change of the volume with respect to the time, is equal to, we have the 10, the derivative of x with respect to the time times the y plus 10 times x times derivative of y with respect to time. Now we can substitute the value. 10 times the derivative of x with respect to the time, which is equal to 2, times y, which is equal to, y here is given as 6 and the width is equal to 4. When the length is 8 and the width is 6 centimeter. So we can substitute this one, 6 plus 10 times the x, which is equal to 8, times dy dt, which is negative 4, because it is decreasing, so we have to be negative. Therefore, dv dt, which is the one we're looking for, the volume, the rate of change of the volume with respect to time, simplifying this one will become 200 centimeter cube or cubic centimeter per second. This is the one we're looking for, the rate of change of the volume with respect to the time, which is negative 200 centimeter cube per second or cubic centimeter per second.